Okay, YouTube, in this video we're going to continue our exploration of solving triangles, especially oblique ones, but we're going to focus on instead using the law of cosines. And this, as a matter of fact, I'm just going to make a small note here. They are listed thusly, and we'll talk about their patterns in just a moment, but basically these are good when you have a side case or a side angle side. And what I mean here is two sides in their included angle. That is, given some triangle right here, we would need to say know a side, and know the angle that is between them. They are included angle, okay? So we are going to look at an instance in this video in which we require the use of law of cosines, but we're going to talk about also why we need to use the law of cosines instead of law of sines. So the law of cosines itself, you notice that it's given three legs on a triangle, or three different sides of a triangle. I'm going to draw on some triangle right here, and as a matter of fact, I'm going to go ahead and label it out as I would if I had these values here, but we say looks like uppercase A here. You know, I'd say maybe this one down here. I'll just rule this as not being drawn to scale, but this is A, and that's a 60. We don't know lowercase a opposite, but we do know that C and B, excuse me, these two sides, we would have to have B be the smaller of the two, and then C would have to be this one down here. So we say C is 30 and B is 20. And I may not have drawn this to scale, but this is what I conceive of this looking like here. So we say uppercase B. But essentially what you can see here is that if I were to write these out also, thusly, we have no side angle pairs. That is, we know, we know uppercase A, but we don't know lowercase a. And you know, if we knew B and C, that'd be great, but we don't know them. But we do know that lowercase b is 20 and uppercase, or lowercase c, excuse me, is 30. So if you arrange your data this way, you see you have no side angle pairs anywhere on this triangle, then we get relegated to using the law of cosines. That is when we'll use it, okay? So knowing this, what we need is two sides and their included angle, or all three sides, to solve for some unknowns. But these equations, they all are similar in that they start off very Pythagorean-like. That is a squared plus b, a squared equals b squared plus c squared. Now that's not exactly Pythagorean, but it really reminds me of that. Or you could even think of this last one down here. But we have a squared equals the sum of the squares of the other two sides. Okay, and this will be minus now 2bc. Now it's bc on this one because these were the two other sides besides a that you had here. You had squared and summed. So you just copy and paste those here, and then when we say cosine, well, it's the law of cosines. And cosine of what? Well, angle A. It's because we start with lowercase a. So all of these down here we could say is b squared equals the sum of the squares of the other two sides, so a squared c squared minus, so minus 2 times a times c times cosine of b, because this started with b. So in this particular instance, what I want to do is I would like to solve for, say, a side length here. I want to go solve for this lowercase a. So using my law of cosines formulas, I have a squared equals b squared plus c squared minus 2bc cosine, and it would have to be cosine a. So let's go ahead and plug in what we know. We don't know a squared. We know that b squared would be 20 squared plus c squared is 30 squared minus 2, and then we can just copy and paste these numbers as we mentioned, and this would be cosine of a, and cosine of a is 60 here. So now in most instances we'll get our calculator out and we'll rock these values, but these are pretty straightforward. Even the cosine of 60 is a half, we know this. So we'd say a squared equals, well, this would be 4 with 2 zeros plus 9 with 2 zeros. 2 times 20 is 40, and 40 times 30 would be 1200, and we have cosine of 60 is actually, we said that's a half. So really we get this here, we get a squared is equal to 1300 minus, now we have to multiply all this first. We can't just subtract straight across. We say 12 times, 1200 times a half would be 600. And so if we subtract these off, we get a squared is equal to 700. And so at this point we could say, well, what is a equal to? A is equal to the square root of 700. We take the square root of both sides here. And so that'd be the square root of 100 times 7, which is 10 root 7. So it is exactly 10 root 7 in length. And because we're doing an application problem here, we should get a value for this. So we could also say 700, the root of this, about 26.46-ish. So 26.46-ish units. And I didn't label this with units, but I'm going to go fill this in up here, 26.46. I'm going to also go put it in our data matrix here, units. And so interestingly, we should round this to 26 and a half, honestly. We're going to call this 26 and a half. But now we have a side angle pair, and so to go solve for the other parts of this triangle, for instance, this angle B here, angle C, I would rather solve for C because it's bigger. Go big or go home. So we say sine of C over lowercase c, which is 30, is now, we could set this up with law of sines, because we have now the sine of angle A over the side that we discovered opposite A is at 22.5, and then we can work backwards and solve for C. So the idea here is essentially once we get C, then we would know B as well. But the point I'm trying to draw out is that this is how you use the law of cosines. And in terms of solving an oblique triangle situation with law of cosines, I will tell you this. Once you do that, I mean, imagine all of this data up here. We filled in the lowercase a. Say we had found uppercase B or uppercase C. Say we did, hypothetically. We would instead have a side angle pair with B or C, respectively. So the idea here is that you'll only ever need to use the law of cosines once, because once you do that, you'll have a side angle pair. And then we could pursue the law of sines, which is just, its own set of videos in and of itself. So in the next video, we'll look at, this was the side angle side case. Two sides and include angle. We'll look at the side case. Cheers.